Welcome to the debate. Today, we're diving into, really one of the most significant industrial shifts happening right now, the huge move in mining towards autonomous haul trucks, AHTs, and these advanced smart mining systems. We're seeing massive investment pouring in everywhere, from Komatsu's front-runner systems scaling up at Nevada gold mines to these enormous zero-emission deals popping up globally. And the real question, the core tension behind these billions being spent, seems to be about the fundamental motivation. Is this rapid AHT adoption driven primarily by, let's say, the classic need for better operational economics and cost control? Or is it now actually a response to the accelerating pressure from environmental, social, and governance ESG and decarbonization mandates? My position? Well, it's pretty clear. Operational economics, the absolute need to maximize productivity and slash the unit cost of extraction. That's the essential, the defining driver that makes this tech viable to begin with.
I see it slightly differently. While efficiency is, undeniably a key benefit, I'd argue that the sheer scale and the speed of these strategic investments, they're really being mandated by external pressures. I think the primary force shaping this whole transformation is that long-term, frankly, non-negotiable push for zero-emission technology. And that's driven by capital markets, regulations, ESG requirements. We're talking strategic necessity here, not just, simple efficiency gains.
Okay, let's start with the hard numbers, the ones that really underpin my argument. For mining operations, autonomy isn't just nice to have, it's becoming a fundamental cost imperative. Why? Because the financial benefits are proven, they're pretty immediate, and they're quantifiable, really regardless of any specific climate target down the road. I often call AHTs a variance product, because variance, that's the enemy of profit in this business. We've got McKinsey data highlighting that these autonomous systems can cut overall mining costs by up to 15%, while boosting productivity by a pretty staggering 20% over time. Now, how does that happen? The return isn't just, trucks driving faster. It really lives in eliminating human variability. It stops that drift in productivity you see across shift changes. It standardizes speeds. It limits idle time. And crucially, it removes human error from the planning equation. You get consistent, predictable 24/7 utilization. And when we look at deployments like Nevada gold mines using the front-runner system, they're integrating these massive 300-ton trucks to unlock efficiencies across the entire mining cycle. That financial predictability, that's the core metric that global finance teams latch onto to justify the huge capex involved. As industry experts like Andrew Leclerc have put it, this move to cut unit costs by controlling variance, it's basically becoming necessary just to stay competitive globally.
Okay, I definitely recognize the power of those productivity numbers. I do. But I'm sorry, I just don't buy that the main driver is simple internal cost cutting when you look at the sheer size of the commitments being made right now. My perspective is that the really big deals, the landscape-changing ones, are fundamentally tied to specific, very high-stakes decarbonization targets. Just consider the evidence. That massive $2.8 billion partnership between Liebherr and Fortescue. And it's centered on the autonomous battery-electric T264 truck. Let's be clear, the T264, that's an ultra-class haul truck, a huge vehicle. Scaling zero-emission tech for things that haul hundreds of tons, it's incredibly difficult and expensive. Fortescue explicitly states this move is essential to hit its 2030 Real Zero target. That's a commitment to eliminate all Scope 1 and 2 emissions. And Scope 1, just to clarify, those are the direct emissions from the site, mostly from burning diesel in those enormous trucks. So when a company commits, $2.8 billion, aiming to replace 2/3 of its fleet with zero-emission solutions, that objective has to be strategic, right? It's driven by external forces, not just shaving a few points off the operating cost. Mariana Ruiz at Deloitte pointed out that these kinds of verifiable emissions cuts are critical for your ESG report card, which, let's face it, directly impacts your access to capital. Even looking nationally, you see China's Huaning Yimin mine operating 100 fully driverless battery-powered haul trucks. They explicitly state it aligns with the national decarbonization strategy, cutting 30,000 metric tons of carbon annually. That kind of scale, it's defined by policy and climate commitments, and that's what's forcing the technology adoption.
I see why you'd connect policy directly sale. Absolutely. But let's look a bit closer at the financial timeline here. My assertion is that the ROI, the return on investment, is fastest and most immediately realized when you link it directly to operational metrics. AHTs pay back quickest, often, within just 1 to 2 years, by maximizing tonnage predictability and cutting down that non-productive idle time. That rapid return, it minimizes the risk associated with that massive initial capex. So it's a cost-cutting tool first, because those efficiency gains translate instantly to unit cost reduction, and that provides the financial confidence needed to then take those bigger zero-emission leaps later on.
But you might be confusing the fastest ROI with the largest strategic value. And I think that distinction is really crucial when we're analyzing these multi-billion-dollar deals. Fortescue, for instance, didn't just meet their initial order for those T264s. They recently tripled it to 360 trucks. That kind of unprecedented scale, well, it isn't driven by a quick 2-year payback window. It's driven by a long-term, frankly, non-negotiable hedge against a future economic reality. These zero-emission investments, they serve as a pretty robust financial hedge against volatile fuel prices and, crucially, against future carbon taxes and levies, which we're already seeing tighten globally. And beyond diesel, think about underground mining. Autonomous battery electric tech offers a massive cost advantage there. Why? Because battery electric vehicles don't need the enormous energy-hungry ventilation infrastructure required to clear diesel fumes. You can slash, 40% to 50% of the mine's total energy consumption right there. So that long-term insulation from carbon costs and volatile energy markets, that's the ultimate financial driver. It's mandated by ESG-conscious investors who demand viability in a carbon-constrained world. The investment is increasingly driven by the need to access green capital pools like green bonds, which often offer lower interest rates. So the cost of capital itself becomes the true economic engine pushing this.
Okay, that is a sophisticated argument for framing ESG as a strategic financial driver. I'll grant you that. But hedges, well, they really only pay off in the more distant future, don't they? Management teams, they're judged on quarterly and annual returns. If the underlying autonomy system didn't guarantee those tight cycle times and that, say, 20% productivity lift, that multi-billion-dollar zero-emission commitment would simply be far too risky for most boards to underwrite. The operational economics have to justify the financial risk of the technological leap first. Let's maybe turn to safety for a moment, which is always framed as an ESG benefit, part of the S component, right? I would argue that safety, in reality, is an integral and, frankly, essential part of the operational economic calculation itself. Reducing operator exposure directly reduces injury risk, it lowers liability, and it directly cuts insurance premiums and costly operational interruptions. Barrick CEO Mark Bristow, he framed this perfectly when discussing their deployments. He said they are, and I quote, creating safer environments by reducing operator exposure while unlocking efficiencies. See? Safety isn't just some optional add-on. It's a required input for achieving maximum operational stability and therefore cost control. An autonomous fleet is reliable precisely because it removes many human incidents, and a reliable fleet is fundamentally a profitable fleet.
I wholeheartedly agree that safety is paramount, absolutely. But arguing it's merely a component of operational cost, I think that misses the larger point about the S, the social aspect of ESG. Because the social dimension introduces major non-financial complexities that pure economic efficiency, well, it often struggles to accommodate easily. Think about it. If the primary goal were simply efficiency and cost reduction, wouldn't companies just move ruthlessly to automate and cut headcounts without much thought for remediation? But we see a crucial constraint in play, the need to maintain the social license to operate, the SLL. That's the ongoing acceptance of a company's operations by its employees, its stakeholders, the local community. And without that license, frankly, the mine cannot function smoothly, no matter how efficient its trucks are on paper. This is exactly why labor groups, like the United Mine Workers of America, raise very serious concerns about job security. And academic experts like Dr. Meredith Tanaka warn that retraining and reskilling efforts absolutely must keep pace with the technological disruption. Because of this intense scrutiny, NGM hasn't just replaced drivers carte blanche. They have publicly pledged retraining programs and committed to maintaining local jobs there in Nevada. This tension, the real cost incurred for retraining, the managed transition timelines, it proves that social viability is a primary constraint. It significantly complicates that pure economic efficiency model because management has to spend money on these, let's say, non-mandatory programs just to preserve their right to operate.
I think we need to unpack that slightly. Managing the SLO, as you put it, is fundamentally about mitigating risk, isn't it? While those retraining costs are certainly real, you could argue they're a defensive expenditure. They're designed to preserve operational certainty and prevent potentially far more costly shutdowns or protracted regulatory fights. So in that sense, the social cost is still being managed primarily to preserve the underlying operational model. It's an expense justified by preventing an even larger potential economic loss down the line. But let's talk about the capex that has to come before any of that operational certainty, the digital infrastructure. The whole operational model we're discussing requires a massive capital outlay for digital infrastructure, specifically things like the private 5G networks deployed by companies like Sedna and Nokia across large mining complexes, like those in Nevada. This infrastructure, it's a huge expenditure, and it has to be justified by the need for continuous, real-time data flow. That's essential for operational confidence and for the long-term systems integration needed. Komatsu's Braden Weisheit emphasized this point. It's about achieving operational confidence and ensuring robust uptime, which is absolutely critical for safety-critical autonomous operations. The network is fundamentally there to prevent systemic failure, which would be, without question, an economic catastrophe for the mine. So the network exists primarily to maximize operational uptime and guarantee that those physical machines run 24/7 without interruption.
Well, the potential problem with that analysis is that you seem to be only considering the internal need for uptime. I'm not fully convinced by that line of reasoning because I think it neglects the equally vital external demand for accountability and transparency. That digital infrastructure, yes, it enables uptime, but it also provides the terabytes of data required for compliance and, crucially, for external ESG reporting, which, as we've kind of established, links directly back to the cost of capital. A 5G-enabled mine uses sensors not just for controlling the trucks, but to drive decision-making around fuel optimization, energy consumption monitoring, and emissions reductions tracking. This level of data visibility, down to the minute practically, is precisely what institutional investors are now demanding. They need it to prove those Scope 1 emissions cuts and compliance with increasingly rigorous ESG frameworks. You simply cannot get those attractive green bonds or favorable lending terms anymore without this infrastructure in place to quantify and verify your decarbonization success. So, in short, the network's existence is, I'd argue, tied directly to proving ESG viability to those crucial external stakeholders. That massive capital outlay becomes a condition of accessing future capital, making ESG compliance a foundational justification for the network itself, not just a tool for maximizing internal efficiency.
Okay, but the data allows for optimization that achieves both ends simultaneously, right? Lower costs and lower emissions. But the speed of the ROI, the thing that gets the initial investment improved, often comes from the tangible cost reduction first.
But the sheer scale of the investment, especially the zero-emission ones, seems defined by that zero-emission target. You could say the structure of the zero-emission investment forces the infrastructure upgrade, which then allows the efficiency gains you're citing. It's a question of which comes first in terms of strategic priority.
I still maintain that the core driver, the fundamental anchor for AHD adoption, lies in those proven cost reduction metrics. That potential 15% cost reduction, the 20% productivity lift, and the resulting ability to control operational variability. That kind of control is, well, it's the absolute definition of competitiveness in a highly volatile commodity market. While the ESG benefits, like decarbonization and enhanced safety, are certainly critical and welcome, they often function more as positive byproducts, emerging from that core pursuit of economic optimization and operational excellence.
And I'd conclude that the largest, most strategically significant investments in AHTs we see today are fundamentally defined by the zero-emission mandate and the intense compliance pressures stemming from capital markets and global policy goals. The massive scale of deals like Fortescue's $2.8 billion battery electric shift and the policy-driven moves in places like Asia. They prove, I think, that these external ESG forces are compelling a redefinition of financial viability, one that mandates this technology shift, moving beyond simple, routine cost cutting toward a necessary long-term strategic transformation.
Well, this discussion certainly highlights how the pursuit of operational efficiency and the need to comply with ESG mandates have become increasingly intertwined in modern mining strategy. It's hard to pull them completely apart.
The central tension, though, it remains. Which factor truly drives the initial decision and justifies the unprecedented scale of investment we're witnessing? It really compels us to keep considering how factors like the cost of capital, those necessary workforce upskilling initiatives, and the demands of external reporting ultimately shape the long-term definition of what constitutes a successful return model in this new era.